Here's an interesting question. A buffer of pH 7.8 is prepared by taking 200 cubic centimeters of a 0.02 mole per cubic decimeter tris solution. Tris is a very common buffer in biochemistry and chemistry, so that's quite a relevant question. And adding dilute hydrochloric acid from a burette until the pH is correct. So we want to have this pH of 7.8. And it says here it is required that we use 1.35 cubic centimeters of a 2 mole per cubic decimeter hydrochloric solution. And we need to find out what is the pKa of this tris buffer. So first of all, I suggest that we convert the cubic centimeters into cubic decimeters so that we can do calculations easier. So we can say that 200 cubic centimeters, that is the equivalent of 200 times 10 to the minus 3 decimeter cubed, because the conversion of cubic centimeters into cubic decimeters is a factor of 1,000. And we can do that for the hydrochloric acid as well. So we have 1.35 times 10 to the minus 3 cubic decimeter for the hydrochloric acid. So let's calculate the amount of tris in moles that we have from our solution here. So we know that we have 200 cubic centimeters in this solution. So we calculate the number of moles of tris that we have in our original solution. And we can do that quite easily. I use dimensional analysis, but you can use whatever method you want to use. So we have 0.020 mole per decimeter cubed. That is basically here our concentration. We want to find the moles, so that's all right here, but we need to get rid of the decimeter cubed that we have down here. So we just simply multiply it with the volume that we have here, which is 200 centimeters cubed, and we just said this would be 200 times 10 to the minus 3 decimeter cubed. So the units cancel out, and we get a total of 4 times 10 to the minus 3 mole. So that's our total amount of mole that we have here with the tris. And what we do now is we add hydrochloric acid to the solution. Now let's calculate the amount of hydrochloric acid that we add. So mole of hydrochloric acid that we add. And we do a very similar thing. We have 1.35 of a 2 mole per cubic decimeter, so we say we have 2 times 10 to 2 mole per decimeter cubed, and we add 1.35 times 10 to the minus 3 cubic decimeter. That is the 1.35 cubic centimeters. And as we see, the cubic decimeters cancel out. And we can do that. We don't need to use a calculator. 2 times 1.35. That gives me 2.7 times 10 to the minus 3 mole here for the hydrochloric acid. So what will happen? Well, we have our tris and we add the hydrochloric acid, and therefore we get the tris hydrochloric acid reaction. And what we see here is that from these 4 millimole of tris, 2.7 will be converted into the hydrochloric acid, into the acid form. So we would have the acid form that would be 2.7 times 10 to the minus 3 mole, whereas the base form, that's the tris, that would be 4 minus 2.7 times 10 to the minus 3 mole. And that gives me, if my maths is correct, 1.3 times 10 to the minus 3 mole. And what I can now do is I can just simply use the Henderson-Hasselbalch equation. Henderson-Hasselbalch equation. And we can write pH equals pKa minus the log to the base of 10 of the acid concentration divided by the base concentration. You can also write it as plus here, but then you would have base over acid. So it doesn't really matter which way around. I'm just more used to the minus. Now we know that the pH is 7.85. So all we need to do is we need to rearrange this equation to find the pKa. So we get the pKa equals the pH. So we bring the log term to the other side, plus log to the base of 10, where we have acid over base. And what we really need to do then is just simply put in the numbers that we've calculated. So pH we said is 7.85 plus the log to the base of 10, and we've calculated here the moles, and because they are of course in the same volume, we don't need to worry too much about the volume. So we've got 2.7 times 10 to the minus 3 over 1.3 times 10 to the minus 3. And when we put this into a calculator, we get a pKa. Well, let's just quickly do that. Let's get a calculator up and running. Where is a calculator? Here's a calculator. We have 7.85. There should be a decimal place. 7.85 plus the log of 2.7 divided by 1.3, close the bracket, and we will get a pKa of 8.17. Let's say 8.17. 8.17. And that would be our pKa of tris base. And if you look at the literature, tris is slightly temperature sensitive, but it's in the range of 8.1 to 8.2. So this result looks pretty good. I hope this makes sense, and